Part 3, voltage and current in a circuit where we have a capacitor. So the voltage across a charged capacitor, first we are talking about the charged capacitor, since if the capacitor is not charged, then the voltage will be equal to 0. Now, when the capacitor is charged, then its voltage is given by U of the capacitor equal Q over C, the quantity of charge over its capacitance. So this is in Coulomb, this is in Farad, and this will be in volt. Now, for a chosen direction, if we want to talk about the current in a circuit where we have a capacitor, for a chosen positive direction, in this direction where we have a dry cell, and the current will be given by I equal dQA by dt, which is here we have the positive part, the negative part. So, and we know that Q is equal to C times UC. So this will give us, in this case, I equal C duc by dt. Okay, so how did we get this part? We said that I equal dq by dt, which is equal to d cuc by dt. Since c is a constant, so we can put it outside the derivative, then it will become duc by dt. This is I. Now here a remark. So since if I want to talk about the current in terms of the other plate is negatively charged. So in this case, I can say that I equal minus dqb by dt. Now, in the case of positive direction, other positive direction is chosen where I don't have a dry cell. So here in this case, we notice that as if the dry cell is the capacitor. So this is the positive part, this is the negative part. If you notice here, now the current is going out from the positive plate, where in the last part, the current was entering the positive plate. So here we'll get I equal minus dq over dt. And if we want to take it in terms of QB, which is negative, then we'll have I equal dQB over dt. And since Q is equal to C times UC, so I just do a substitution and I will get this answer. I equal minus C duc over dt. We'll see that this case is called the discharging process of the capacitor, while the previous part will be called the charging state of the capacitor. Example, a capacitor is made from two flat parallel plates placed at 0.4 millimeter apart. And when so we have here is the distance. When a charge of 0.02 microcoulomb is placed, so this is a Q on the plates, the potential difference between them is 250 volts. So this is UC. The first question is calculate the capacitance of the plates. So in order to calculate the capacitance, we can directly say that Q, so this is part 1, Q is equal to C times UC. And we have here the charge, and we also have the voltage. So implies that C equals to Q over UC, which is equal to 0.02 times 10 to the power minus 6 and over 250, then we'll obtain the capacitance. Now, the question number 2, the charge on the plates when the potential difference between them is 500 volts. So now all we did is we change the voltage. We must pay attention that even if we change the voltage, the capacitance is a characteristic for the capacitor. So it's constant here. Then we will say that now the new charge, Q, for example, 1 is equal to C times UC. Now UC will be equal to 500 volts. So it will be equal to the capacitance that we found here, okay, times 500 volts. And the answers will become, this will be equal to 8 times 10 to the power minus 11 farad. Then it's 8 times 10 to the power minus 11 and times 500, which will give us 0.04 microcoulomb, which is 0.04 times 10 to the power minus 6 coulomb.